Now students, we see the practice set 2.1. The first in first example, identify the reason which the following are Pythagorean triplets. That means we have to check this is Pythagorean triplets or not. Now we take here two examples in this, example number 2 and example number 4. First, example number 2. In this example, 4, 9 and 12, these three numbers are given, which they are asking us they are Pythagorean triplets or not. In this, 12 is the greatest number, that means we have to get the square of that number. The square of 12 is equal to 144. The square of 4 is 16 and the square of 9 is equal to 81. Now we have to add these two, and if this is equal to the square of greatest number, then they are the Pythagorean triplets. Now the square of 4 plus square of 9 is equal to 16 plus 81, hence which get 97. And the square of 12 is 1444, hence the 4 bracket square plus 9 bracket square is not equal to the square of 12, and hence this is not a Pythagorean triplets. Therefore 4, 9 and 12 are not a Pythagorean triplet. Because of the converse of Pythagoras theorem. Converse of Pythagoras theorem. Now we see the second example, that is fourth example. 24, 70 and 74, these three numbers are given. The square of 24 is equal to 576. Square of 70, the square of 7 is 49, and we will write 20, that is 4900. Square of 74, that means we have to multiply 74 into 74. This multiplication, we get the square of 44 is 5476. Now the sum of these first two, the 74 is the greatest number, hence the 24 bracket square plus 70 bracket square is equal to 576 plus 4900, hence which is equal to 5476, which is equal to 74 square, and hence 24 bracket square plus 70 bracket square is equal to 74 bracket square, and hence by the converse of Pythagoras theorem, (24, 70 and 74) is Pythagorean triplet. Now we see another example. in the book. We see the selected examples. Now the seventh example, which is also important. In this figure, DEF is 90 degree is given, and FG is perpendicular to ED is given. And if GD is equal to 8, GF is equal to 12, then we have to find EG, FD and EF. Now we see this example. In figure, FG is 12 given and GD is 8. FG is perpendicular to the GD. GD is the hypotenuse, and hence by the theorem of geometric mean, we get the square of GF bracket square is equal to GD into EG. By the theorem of geometric mean. Hence we get GF is 12 bracket square is equal to GD is 8 into EG. Take 8 to the another side, we get 12 into 12 upon 8 is equal to EG. Simplify this, 4 2s are 4 3s are 2 into 6. Hence EG is equal to 3 into 6 is 18. We get one side EG is equal to 18. This is 18. Now these are right angle triangles, these two small triangles. We solve this by Pythagoras theorem. Hence first, in triangle FGD, FG square plus GD square is equal to FD square. That is by Pythagoras theorem. Hence first I write FD square is equal to GF square plus GD square by Pythagoras theorem. Hence GF is 12 bracket square plus GD is 8 bracket square. Hence the square of 12 is 144 plus square of 8 is 64, and hence the sum of this is equal to 208. Hence FD square is equal to 208. Therefore FD is equal to into root 208. We have to simplify this. 208 is equal to 16 into 13. One number is perfect square. We have to get factors such that the one number is perfect square. 16 into 13 is equal to 208. Take the 16 outside the root sign, and hence we get FD is equal to 4 root 13. That is our second value. And third value, for third value we take this FGE right angle triangle. In triangle FGE, EF square, that is the hypotenuse, is equal to EF square is equal to EG square plus GF square. EG square plus GF square. This is also by Pythagoras theorem. And hence we get EG is 18 bracket square plus GF is 12 bracket square. Hence the values of 18 square is 324 plus the 12 square is 144. The sum of this is equal to 448, 6 and 4. 468 is equal to EF square. Now we take the square root. EF is equal to into root 468. Now EF is equal to into root 468. Hence we have to simplify this. We get 36 into 13, and hence take this 36 to this outside the root sign. We get EF is equal to 6 root 13. Now we see the another example, 9, which is also important. Let's get a star at here. In the figure, M is the midpoint of QR. That means RM is equal to QM is given. R is 90 degree. Then we have to prove that PQ square is equal to 4PM square minus 3PR square. PQ square is equal to 4PM square minus 3PR square. Now we see this example. This is a simple example. First we have to draw the figure. We have to prove that PQ square is equal to 4PM square minus 3PR square. First, there are two right angle triangle. One is PRQ and another is PRM, which is small, and the PRQ is the big right angle triangle. First we take the big right angle triangle. Here in triangle PRQ, PR square plus RQ square is equal to PQ square. This is equation number 1 by Pythagoras. Okay, now we get the second small right angle triangle. Now here one thing is given. M is the midpoint of RQ. That means RM is equal to MQ is given, and hence RM is equal to this half of QR upon 2. This is equation number 2. RM is equal to QR upon 2. Now we take the small triangle. In triangle PRM, that is a right angle triangle. Hence PR square plus RM square is equal to PM square. PR square plus RM square is equal to PM square by Pythagoras theorem. And hence we get RM is equal to QR upon 2. Therefore PR square plus QR upon 2 bracket square is equal to PM square. Solve this bracket, we get PR square plus QR square upon 4 is equal to PM square. Here the 4 is the denominator. We have to multiply the equation by 4. We get 4 PR square plus 4 into QR square upon 4 is equal to 4 PM square. Multiply equation by 4. Multiply the equation by 4. 4 get cancelled. Hence 4 PR square plus QR square is equal to 4 PM square. Take this 4 PR square to the another side. We get QR square is equal to 4 PM square minus 4 PR square. Now substitute this value in the equation number 1 because this is a RQ, that is QR square. Hence PR square plus QR square is equal to PQ square by equation 1. Substitute this value at here. We get PR square plus 4 PM square minus 4 PR square is equal to PQ square. PR square minus 4 PR square, we get 3 PR squares. Hence 4 PM square minus 3 PR square is equal to PQ square. Right? Here is PQ square first. Hence PQ square is equal to 4 PM square minus 3 PR square, which is proved.